review part 2. So in this case, we don't know what's beside our log, and we don't know what's beside our log or in our base, which we actually don't know what's beside our log or in our base in this case. We always convert to exponential. So we're going to use the outside log. So we're going to get 5 to the 0 equals log base x of 2x minus 3. 5 to the 0 is 1 equals log base x to the 2x minus 3. And now we still don't know what's beside log, so we're going to change to exponential again. So we're going to get x to the 1, base of the log because the base of my exponent, to the 1 equals 2x minus 3. And solve for x. Subtract 2x. Negative x equals negative 3. 5 by negative 1. X equals 3. And we can check it with our calculator if we'd like. So we could have math. Log base 5. And there you have math log base x of 2x minus 3. And then y2 would be 0. Second trace 5. Enter, enter. And we get 3. So we know we're right. All right. The next one, we have 2 logs. They're base 10. So because they're both base 10, we get them on one side, everything else on the other. On the other is 0. And now we can put them together because they both have plus 1s in front of the log. So we can put them together by multiplication. So we have log base 10 of sine x times 2 sine x minus 1 equals 0. Now we don't know what's beside the log. So when we don't know what's beside the log, we convert to exponential. So we're going to get base 10 to the 0 equals sine x bracket 2 sine x minus 1. 10 to the 0 is 1. So 1 equals sine x bracket 2 sine x minus 1. So because it's not equal to 0, we have to remember to expand it to distribute. So we're going to get 1 equals 2 sine squared x minus sine x. And the moment we have a squared, we have a quadratic. So we move it all to one side. So we get 2 sine squared x minus sine x minus 1. If we want, we can replace our sine x with m in order to do decomp. So I get 2m squared minus m minus 1 equals 0. What multiplies to give me 2 and adds to give me negative 1. Negative 2m plus 1m. Group. Take out a 2m. You're left with m minus 1. Oops. Take out a plus 1 because you can't take anything out. M minus 1. So I have 2m plus 1. M minus 1 equals 0. And when I solve them, I get m equals negative a half. And m equals 1. Now m is actually sine. So we have sine x equals negative a half. And sine x equals 1. Well, where does sine x equal negative a half? At 30-degree reference angles of pi over 6 in quadrant 3 and 4, because that's where sine is negative. So this would be 7 pi over 6. This would be 11 pi over 6. Or you could say 210 and then change it to radians. And you could say 330 and change it to radians. And then where does sine x equal 1? Well, where does y equal 1? At pi over 2 or 90. So x equals pi over 2, 7 pi over 6, 11 pi over 6. Okay, the next one says simplify, so we're not solving now. Couldn't punch into my calculator, I don't have an equal sign. But there's a way that we can solve these, or simplify, sorry, not solve, simplify each of them separately. So remember when we have log c to the c to the 4, it's just 4? Well, why is that? Because you can take the 4 and drop it in front, and it would be log base c of c. And this is just log base c divided by log base c, which is 1. So it's actually just 4 times 1, which is 4. So whenever you have base c to the 4, your answer is always the exponent. Then minus. When you have log base 6 at 36, you can do it in your head because you can say 6 to what power is 36? And it's 2. So we're going to subtract 2. When we have the same base of the exponent as the base of the log, your answer is just what's beside the log. So it's 3. You get plus 3. And then for the last one, just like saying 6 to the what is 36, 6 squared, you're going to say k to the what is 1, and k to the 0 equals 1. So my answer is actually 0. So I'm going to get 4 plus 3 minus 2, which is 5. That whole thing turned out to be 5. Number 2, given log b of 36 equals 2 and log c of 125 equals 3, where b and c are greater than 0, which they have to be, the base, determine log 1000 BC in the form p plus log r. The value of p plus r is. So this is what they really want us to solve, or to simplify, I guess. So log, there's no base, so I'm going to write base 10 so that I know that I can use it. 1000 is multiplied by b is multiplied by c. Okay? This I can expand. They're all multiplied. So I could expand that as log base 10 of 1000 times log base, or sorry, plus log base 10 of b plus log base 10 of c. Now, why would you want to expand those? You'd want to expand those because log base 10 of 1000 is actually just a number. It's 3. So you're going to get 3 plus something. Well, where could we get those somethings from? Well, over here we have log base b of 36 equals 2. Well, we could solve for b. We don't know what's in the base. We don't know what's in the base, or we don't know what's beside the log, we convert to exponential. So we're going to have b squared equals 36. And then we're going to take the square root. And when we take the square root, we get plus or minus. And then we have b equals plus or minus 6. The catch is, though, that b is in the base, and we can't have a negative base. So the negative is not an answer. Also, in the question, it said b and c is greater than 0. So I know b equals 6. So I can go log base 10 of 6. Then I have log base c of 125 equals 3. I can convert to exponential because I don't know the base. C cubed equals 125. Cube root c. And c equals 5. So plus log base 10 of c, which is 5. Now, they want it in this form. So they want the logs together. Because they're both log base 10 and they have positive 1s in front, we can actually put them together. So that's going to be 3 plus log base 10 of 6 times 5, which is 3 plus log 30, because you don't need to write the base part. And now it matches up. P plus log r. So I want the value of p plus r. So 3 plus 30 equals 33. Okay, then we have 2 word problems in logs. The earthquake word problem. It follows the formula intensity equals 10 to the m1 minus m2. Remember, there's a catch. If the intensity is large, so greater than 1, for example, I would equal 2, so 2 times as intense, 100 times as intense, 50 times as intense. So if I is big, M1 is the big earthquake. Magnitude. In turn, then, if I is between 0 and 1, so small, for example, if I is a third is intense, a quarter is intense, half is intense, then your M1 is the small earthquake. So M1 changes depending on which intensity you have. And they don't always give you M1. Sometimes you have to find M1. So let's read the question. An earthquake in Peru has a magnitude of 7.7 on the Richter scale. The following day, a second earthquake with 1/3 of the intensity of the first hit the region. Determine the magnitude of the second earthquake. So we know our intensity is 1/3. So I'm going to fill 1/3 in for I equals 10. Now M1, because my intensity is small, my M1 is small earthquake magnitude. Can't really tell, but that's a subtraction sign. M1 minus M2. Okay, so we have to decide, did they give me the big one or did they give me the small one? An earthquake in Peru had a magnitude of 7.7 on the Richter scale. The following day, a second earthquake with 1/3 of the intensity. So the smaller one is the second earthquake. Determine the magnitude of the second. So they're making us find the smaller earthquake. They gave us a small intensity, so the smaller earthquake is M1. We don't know what it is. We're going to subtract off the smaller one. If you made a mistake in putting it in the wrong spot, you know, because they gave us the bigger earthquake, we know that our answer for magnitude is going to have to be smaller than 7.7. So if it's bigger, you put it in the wrong M. So I can change this to a log, because if I don't know the exponent, if my x is in the exponent and I don't know it and I can't make common base and I only have one exponent, I can convert to a log. Or you could y1, y2 it. But if they wanted it algebraically, that wouldn't be correct. So we're going to check it y1, y2, but we're going to solve it as a log. So we're going to get log base 10 of 1/3 equals m1 minus 7.7. And to get m1 by itself, I'm going to add 7.7. So I'm going to go 7.7 plus log base 10 of 1/3. And I get 7.2. Now I'm going to check it with my calculator. 1/3, 10. So in my y1, I'm going to have 1/3. The second equation is 10 10 to the power of x minus 7.7. Graph. And then second trace 5, enter, enter, enter. And we get 7.2, same answer. So we checked it and it works. Okay, last word problem is about decibels. So we want to know how many times more intense. Now the catch is we use the same formula. Instead of M1 though, we can label it B1 and B2. Follows the same rules, but B stands for bells because this formula only works for bells, not decibels. So even though it's 60 decibels, we're going to put in 6.0 bells. And even though it's 30 decibels, we're going to put in 3.0 bells. Okay, so how many times more intense is the sound of a student talking than a student whispering? Now, because it says more intense, they want the bigger intensity. So the bigger bell has to go faster or go first. So we're going to do 10 to the 6.0 minus 3.0. I equals 10 to the 3. And 10 to the 3 is 1,000. So it's 1,000 times more intense. Okay. Now, if you were filling this in and they had given you the intensity in one of the bells, you would find the other one, just like you did with the previous equation, but you would have to remember to move it back to decibels for the answer. And that's logs review.